Okay, so we'll be starting in a minute. So the next talk is Nakadi Event Broker by Lionel Montrieux.
Yes, exactly.
So, have fun.
Thank you. Okay, so I guess I can start, right? So my name is Lionel. That was fantastically well pronounced. And I'm an engineer at Zalando. I'm sure you've all heard of Zalando before. And I'm very lucky that I get to do open source software and get paid for it. So that's really great. And I work on something that's called Nakadi Event Broker. Nakadi is a Georgian word that means stream. So now that makes a bit more sense for you. And what is it? It's a RESTful API on top of Kafka-like queues. We'll come to that. So Nakadi is entirely open source. You can get it on GitHub and run the exact same version we're running internally. But we have our own deployment, of course, for Zalando. We've got about, I don't know, 150, 200 teams of engineers. And we have an architecture with services, microservices, and REST APIs and JSON format. So they use Nakadi in order to exchange messages between services. And it works quite well. They seem to be quite happy with what we do, so that's quite nice. And, but that's not all. We also use it to archive all the data that should be archived into our own data lake, and then it can be used by researchers and data scientists and BI people and everything. This is our new logo, and it's actually so new that it's not even on the website yet, so you get to see it for the first time. Let's go back to, let's see, what is it? So that's Nakadi. It's a RESTful API on top of Kafka-like queues. So RESTful API, I think that's okay for everyone. Can I ask you to stand up if you use or have used Kafka? Like maybe 1/10 of you, if that. Okay, that's great. And who's heard of Nakadi? Yeah, that guy works with me. So we're going to change that because now you all have heard of Nakadi, right? So Kafka-like queues, they're a bit different than the queues in like something like RabbitMQ or something. So since not that many of you have used it, let's spend a few minutes to do a quick recap, right? So in Kafka and in Nakadi, you can write to an append-only log, right? And you have producers who write, and you have consumers who consume, so they read what's on the log. And here you've got one producer, there could be several ones, and he's writing like messages 0, 1, 2, 3, 4, 5. And consumers, they can say, well, I want to start consuming here, and I'll just sequentially consume everything, and I'll wait when I catch up with the producer for him to write something, and then I'll read it, etc. So the difference is that you can have several groups of consumers, and they can all consume the same amount, all the data. It's not distributed to all of them. So what do you do in Kafka when you want to have more throughput? Because you want to write a lot of messages. We get a lot of messages. Well, you can create partitions. And Kafka guarantees order only within a partition. So the producer gets to write to either partition. He gets to choose, probably, or Kafka chooses for him. And the consumers, they can read from both partitions, and they can write twice as much. So that's really nice. So Kafka is actually a distributed streaming platform. So every partition in Kafka is replicated on a number of brokers in your Kafka cluster. For us, it's 3, but I think you can configure it to something different. And that's how you get a distributed, very highly available system, because any broker can go down, it comes back up. There's no problem. And even while it's down, things keep working. So that's really great. What does it have to do with Nakadi? Well, this is the very high-level architecture of Nakadi. We've got Nakadi sitting between the producers and consumers. In our case, everyone at Zalando, but maybe you. And Kafka on the other side. And what Nakadi does is quite a bit more than just being some sort of HTTP proxy for Kafka, although it is an HTTP proxy for Kafka. It's got a bunch of other features. So in Kafka, you create a topic, as we saw earlier, and that's your append-only log that has a number of partitions. The equivalent in Nakadi is called an event type, but essentially it's pretty much the same. And with your event type, you create it in Nakadi, and it appears in Kafka. Okay, that's all fine. And Nakadi has this nice feature. You can say, well, this is the schema in JSON schema that every single event that is published to this event type is guaranteed to conform to. Yeah. And you can also do schema evolution. So there are rules to evolve your schema in only a forward or only a backward compatible way, so that all your consumers, who you don't necessarily know, have a number of guarantees with regards to their ability to read your messages, even when your schema has evolved. So these are three features of Nakadi. You've got HTTP proxy, you've got schema registry, you've got schema evolution, that forward compatible, backward compatible, not compatible at all if you want. It's a bit more risky. It's got other things too. You can say, well, I don't want everyone to read or write to this event type, and I don't want someone to go and change my schema and then break everything. So you can set per event type authorization rules that define who gets to administer the schema, the event type, sorry. So change the schema, addressation time, a bunch of things. Who gets to write to the event type, and who gets to read from the event type, which is very useful when you have sensitive data to put in there. You can also set an archiver that gets to read everything, by the way. This is new. So that's for the high-level view of Nakadi. And it's got a bunch of other features, but there is one I really want to talk about because I think that's what makes Nakadi different from the competition, which would be something like maybe Confluent Platform or Kinesis on AWS. What we've got is called timelines. New logo. And timelines is really cool because we have that problem with operating our big Kafka cluster. We handle several terabytes of data a day. Is that sometimes you want to move data from one broker to another or from one cluster to another. And that requires copying a lot of data between brokers. And when we do that, we have a big problem. We use more bandwidth, we have more I/O usage, which means that everything slows down for everyone else. And if I can take an example, last year, end of last year, we had to rebalance a cluster because we wanted to add 3 new brokers to the cluster. The rebalance operation took an entire week of copying data around. And for an entire week, we had people complain, why is Nakadi slow? Because we're rebalancing. When is it going to finish? We don't know, but it's probably going to be a week. It was a week. So they weren't happy. And we thought, well, what can we do? Because sometimes we really do need to move data around. There's no way around that. But can we do it without actually copying the data? And can we do it in a way that will not interrupt service, either for consumers or for producers? So we want to be able to move, essentially, an event type from one place to another without no one noticing and without slowdown. And that's what we do with timelines. So let's imagine that we have an event type that is represented by a topic in our cluster A, and we want to move it to our cluster B, right? So we've got one producer right here. He's connected to Nakadi, and Nakadi, on his behalf, writes the messages to the append log in Kafka, and we've got 2 consumers. So these can't be disconnected. They have to be able to keep writing and reading, and the data that is in topic 1 mustn't be moved to the cluster B, because otherwise everything will slow down. Well, we decide to create a timeline. We consider that topic 1 is the first timeline. We say, well, for this event type, I'm creating a new timeline. Bam! There you go. We create a topic, a different topic, in the other cluster. And of course, Nakadi keeps track of the end of the first timeline, which was offset 5. And then immediately, the producer is connected to the other topic, and he's publishing to the new topic. And the consumers, they are still catching up, so they're behind with the old topic. Eventually, some consumers will be reading from the new topic, others will be reading still from the old one. That's fine. At some point, everyone will have caught up. okay? And because these topics, they have a retention time that is set. We set it to 4 days, but you can set it to, of course, however long you want. Eventually, the data in the first topic, in the first timeline, will disappear. It's gone. So at that point, you can just delete the old topic, and everyone is writing to and reading from your new topic, your new timeline. Using this, you can move the data. Well, you don't move the data, but you move your event type from one cluster to another. So we've done that, that's fine. The producers haven't noticed because they kept writing all the time, no problem. So that's fine. The consumers are happy too because they kept consuming. Just a little bit of slowdown at some point for some locking and synchronization, but that's it. And data hasn't moved, so Nakadi hasn't been slow. The first time we used this feature, we needed for a specific event a much bigger Kafka cluster than the one we had. We needed it to be 3-4 times bigger. We could have added more brokers to our cluster, done a 1-week rebalance, have everyone complain for a week, and then at the end of the event, done the same thing, rebalance everything back to only a few of the brokers, another week of complaining, and remove the brokers. I say complaining, but they're right to complain, right? If it's slow, it's a problem. So what we did is we created a new cluster that was bigger. We create timelines for every single event type that we had. We have over 2,000. And everyone immediately started using the second cluster. And then, what did we do? We waited. We left the old one still there because we knew we had to go back to it. After the event, again, timelines for everyone, back to the old cluster. And when the big one was empty, the event was passed, we could just get rid of it very easily. So that's our first use of timelines. Our second use of timelines, we're working on this right now. It's a feature that's coming up. Well, you can use timelines to repartition a topic. If you want more throughput, as I said in the beginning, you want more partitions. Now, it's got a bunch of problems, but essentially you could use timelines, create a new topic that has more partitions. And because we have a very nice consumption API, you will actually, the consumers will also get the data from all the new partitions that they didn't even know existed immediately. And we benefit from all the locking and synchronization we have already implemented in timelines. So that's really nice. Another thing we can do with timelines is, well, actually, who says we need to have only Kafka? Any pub/sub model that works in the same way could work, potentially. And by the way, who said we need to have a single cluster? We can have several ones and configure them differently depending on our users' requirements. And we can move the event types from one cluster to another depending on changing requirements from user, which happens actually quite a lot. So that's it for timelines. Nakadi, you can find it online. The first link is Nakadi itself. It's written in Java. It's a Spring Boot application. There's all you need to get started with Docker images and all you want. Second link is an ecosystem we try to create around Nakadi. There's a bunch of client libraries. There's some for Scala, several ones for Java. There's a Python one, and I think there's a Go one that's coming up at some point. We have a web UI which isn't open source yet, but we're working on it. So you can see things. It's really, really nice. And we're waiting for your contributions. Thank you.
So we have time for 1 or 2 questions. So if anyone has a question.
Any features that we lose by using Nakadi and not Kafka directly? Yes. So one thing we're working on at the moment is log compaction in Kafka. Unfortunately, it doesn't play well with timelines because you have to somehow refeed the data from the old topic to the new one. So we're working on a solution for that, but at the moment you wouldn't be able to use it. This is one example. Yes? Sorry? We don't have immediate plans to do it, but it's a possibility, yeah. That could work. Sorry?
Can you repeat the question?
Oh, yeah. Are we going to support Kinesis as a backend? So you mean like, yeah, there. Yeah, we thought about it. Actually, someone implemented some proof of concept, so it's possible, but it's not production ready yet. If you want to contribute. All right.
Okay, okay. Thank you.
Oh, there's one more.
Are there one more? Okay.
How much state is that? Kind of stateless? Can you
It's stateless.
put out?
Yeah, it's stateless. We use it in, we run it on AWS and we use auto-scaling groups and it just changes all the time.
Okay, okay. I guess time is up.
All right. Thank you.